All right, whenever you have a piecewise function, you have two parts to really look at. So our first part, you already have written x squared minus 4 when x is less than or equal to 1, and negative 3x plus 1 when x is greater than 1. Okay, so whenever you're asked to determine limits, okay, we're asked to find the limit as x approaches 1. Is that correct? Yeah, x approaches 1 of f of x. So of all that crap up there, we got to find out what this limit actually goes to. Okay, so we're going to make it super simple. Okay, we're going to draw a line. All right, and in the middle of that line, we're going to put 1 because that 1 is our dividing line of this piecewise function. So 1 is where the function changes and it jumps to another piece, right? Okay, so less than or equal to 1, which side of 1 is that on? The left-hand side or the right-hand side? The left-hand side. So on the left-hand side of 1, our function is going to match that, x squared minus 4. And on the right-hand side, it's going to match 3x plus 1. So I'm kind of making a graphic organizer. Yeah, negative 3x plus 1. Okay, kind of a graphic organizer for myself. All right, so if we can find the limit over here and the limit over here, if they go to the same thing, then that should be the limit, right? Okay, so how do I find the limit? Can I just plug in? Yeah, so if I plug 1 in here, I get 1 minus 4, which is negative 3. So the limit on this side is negative 3. The limit from the left-hand side. And the limit on the right-hand side is negative 2. Okay? Because negative 3 plus 1 is negative 2. So do these go to the same thing? No. So our limit does not exist. Okay? So it looks scary, but it's not. All right? Not at all. Okay? The next... Sorry. All right? We're going to talk about the next one. Okay, we're basically going to do the same thing. Okay, so we've got x squared plus 3x minus 4 when x is less than 2. Okay, we have 4, just 4, when x equals 2. And we have x to the third. Yeah, x to the third minus x when x is greater than 2. Okay, so kind of a crazy looking function here, f of x. All right, so we want to know the limit when x approaches what value? X approaches 2. Okay, equals blank. All right, so we're going to do the same thing. What's my dividing line here? 2. Yeah, 2 is my point of reference. We know at 2, the limit is 4. Okay? Right at 2, the limit is 4, because that's what it is when x equals 2. Okay? On the left-hand side, we got x squared plus 3x minus 4. All right, so right at 2, the limit's 4. Okay? On the left-hand side, let's see if all of these match. Okay? So the limit from the left-hand side should match the limit from the right-hand side, and that's going to tell me the limit. All right? This, that's not the limit. That's what f is at 2. Okay? So when we plug 2 in, 2 squared, 4 plus 3 times 2 is 6, right? Minus 4 is 6. So the graph approaches a value of 6 on that side. That's from 2 squared plus 3 times 2 minus 4. Okay. Over here, x to the third minus x. So 2 to the third minus 2. What is it? 6. So they both approach 6. So what is the limit of this? 6. Okay, this just happens to be, all right, at 6. So at 6, your graph has got a hole in it, but both those curves approach 6. Okay, and then f of 6 is actually 4. So it's kind of like those graphs that we did yesterday. Okay? Does that make sense?
Yes.
Yeah. All right. Okay, and we'll look at this last one. Can I go on? All right, x over x plus 3 when x is less than or equal to negative 3, and x plus 4 over x plus 3, okay, when x is greater than negative 3. Okay, so again, we're going to do the same exact thing. My dividing line is negative 3. All right, this is x over x plus 3 because it's on the less than side. Okay, this is x plus 4 over x plus 3 because it's on the right-hand side of that. All right. And we're looking for the limit as x approaches negative 3. Okay, so it's 0 over 0, right? Or number over 0. Number over 0, look at my power. The power's 1. That means that this side does not exist. Okay? Does not exist. Now that means it could be going to infinity, right? There's not a number value that we could have. Okay, and over here, you get a number over 0. So again, power, my limit does not exist. All right? So what we would have to do, and I'm running out of time as we go here, these could both mean that the graph goes up to infinity forever. It could mean that they both go down to infinity forever. So what we need to do is we need to try something really, 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 really close to negative 3. All right? So we can plug in negative 2.999999, all right, and see what we get. Okay? Plug in something on the other side. See what we get. If they both go the same thing, all right, in this case, they go to positive infinity. Okay?